All right, let's look at the homework 7.5, 7.6, problem number 9. All right, so we want to minimize this function of two variable subject to this constraint x times y equals 36. All right, so let's do that. All right, so we have to come up with the function capital F, right, of x comma y comma lambda, right, is equal to, right. So I have to rewrite the constraint this way by subtracting 36 from both sides. So we have x times y minus 36 equals 0, right. So this guy is our, right here, this guy is our g of x comma y, right? So remember that this capital F can be found by taking the original function that we want to minimize minus lambda times g of x comma y, right? So therefore, we'll get, let's see, 4x plus y minus lambda times quantity xy minus 36. All right, so let's find a partial with respect to each variable. So capital F, partial derivative with respect to x would be, all right, so partial with of 4x with respect to x is 4, right? Y is constant, so partial with respect to x is 0, right? So here, partial with respect to x would be y, so it's going to be y times, so negative lambda y, right? And the partial of that is 0, so we have that, right? And then partial derivative of capital F with respect to y would be, right, so that's 0, and that's going to give us 1, right? And here, partial derivative of xy with respect to y would be x, so it's negative lambda x, and the partial of 36 is 0. All right, then we take the partial derivative of capital F with respect to lambda, right? So that's 0. That's 0 because there's no lambda in there. Here, derivative of that is going to be, let's see, derivative of that is negative 1 times that. So it's going to be negative xy plus 36. All right, then we set them all equal to each other. All right, so this is going to be 0, and this is going to be 0. All right. Then what we can do is we can probably solve this equation for maybe lambda. All right, so let's do that. All right, so sorry, so let's say solve for lambda. So add lambda y to both sides, so that will give us 4 is equal to lambda y. All right, then I'm gonna just divide this guy through by lambda to get, actually I'm solving for lambda, so let's divide by y. All right, so this is going to be 4 over y is equal to lambda. All right, then we can plug this lambda back in here into the second equation. So we're gonna plug this guy into the lambda here, right? So you will get, let's see, so this is going to give us 1 minus lambda is 4 over y and times x, right, equals 0, right? Then we can just, let's see, add 4 over y, x to both sides. So it's going to give you 1 is equal to 4 over y, x. Then I'm going to multiply both sides by, say, y. So it's going to be y is equal to 4x. All right. Then we can just plug this guy back in here. So here, plug 4x, because y is same as 4x. So you can just plug it in here. All right. So let's do that. So I'm going to go down here. All right. This is going to give us, right, negative x. All right. But y is the same thing as 4x. This is equal to 0. Right, plus 36. And I'm going to go ahead and simplify first. So it's going to be negative 4x squared plus 36 is supposed to be 0. All right. Then we can just, let's see, subtract 36 from both sides. So it's a negative 4x squared is equal to negative 36, right? Then divide through by negative 4, right? So we have x squared is equal to 9, right? Then we know that here, right? Then take the square root of both sides. So x is going to be equal to plus or minus square root of 9 would be 3, right? But to remember that here x and y are positive, so we're looking at the positive value. So right here, all right? Then corresponding y value can be found. We can plug this over here. So I'm gonna probably do this. Go over here, all right? So here's x, right? So we know that y value is 4 times 3, so it's 12. All right. So all right. So let's try to find that. So we're gonna plug in this guy. So you have f of. We just found that the x to be positive 3, and a y to be 12. All right. So we just plug in 3 here. And y is 12. So this is going to be equal to 4 times 3 plus y is 12. So it's 12 plus 12, so it's 24. Right? So that will be the minimal value with that constraint. Right? So let's type it in. All right, so the minimum value we found was 24, right? And then it's at 3, 12. All right, whoops. All right, so let's check the answer. All right, it came back and looks like the minimum value is 24, and we got the critical point correctly. All right, that's it. I hope that this was clear.